Thank you, Yann, for those very interesting thoughts and, I would say contrarian view. It's good to sort of end the day with something that hopefully will generate some controversy and questions. So before we get into AI and talk about some of the things you've mentioned, I want to, we have a room full of people here, humans. And I know that you have said that you don't like the term AGI or general intelligence because you think humans don't have general intelligence. So could you maybe elaborate on that? Because all of us like to feel that we are generally intelligent.
Yeah, we like to think that we have general intelligence. I had this online argument with Demis Hassabis actually about this. We don't. Yeah, I'm sorry to say that, but we don't have general intelligence at all. In fact, we're extremely specialized, perhaps in ways that we don't realize are important, because all of the problems that we can apprehend, that we can imagine an intelligent system kind of being able to apprehend, are things that precisely we can imagine apprehending ourselves. And so we think we are general, but it's just because we have an extremely limited notion of what type of problem we can apprehend. And if anything, computer science has shown us over the last few decades that humans, totally suck at a lot of things that computers are so much better than we are, right? So anything that involves, search through a graph, right? Whether it's your GPS planning a route, or whether it's searching through the, the tree of possible moves for chess or Go or poker. We're really bad at this. I mean, machines are much better than we are, right? It took us a while to get there, but eventually we did. And then let's not even talk about solving equations and stuff like that.
Got it. I guess, part of it is we are maybe slow at certain things, but isn't it the case that humans are able to learn things that they don't know? Like if they have given a new problem, they're able to think through it and figure out a way of doing it. Maybe they're slow, but isn't that generality?
Right, so that was kind of the point that Rao actually made on the panel just before. Having tests like the humanities last exam, it's complete nonsense to measure, to check whether a machine is as smart as humans, because humans have, as I pointed out in my talk, have an ability to learn new tasks extremely quickly. We can only learn a limited amount of tasks, but because it takes a while to learn a new task. And so, all of us are experts at different things here because we've been exposed to sort of different things and we're interested in different things. And this is, why society can make progress, because we're all different, right? That's it thrives on diversity. But the reason for this is that we cannot possibly learn everything. And that's another evidence that we are very specialized, because we have limited time to learn things. And so we can only learn, a limited number of things. And so the ability to, intelligence is not a collection of skills, or at least it's not just a collection of skills. It's certainly not an accumulation of knowledge, which is basically what LLMs are. Okay, LLMs are not particularly smart, except in a small number of domains where manipulating the language actually is the support of reasoning. So that includes code and mathematics, maybe law, but they're not very smart. But what they can do is accumulate a huge amount of knowledge, right? That has been digested, if you want, by humans before they're fed to them. But what about understanding? What allows us to learn to drive a car in a few hours of practice, or solve new problems zero shot in a situation we never faced, is this ability to use our mental world model to basically apprehend new situations extremely quickly and solve that problem zero shot without being trained to do it, or training ourselves extremely quickly to be able to do it. Okay, that's the adaptability ability. I think that is a characteristic of true intelligence.
Got it. So you're obviously one of the pioneers of let's call it machine intelligence or AI. And there's a room full of people here, many of whom are interested in this field. What should be the goal of machine intelligence in your view? Is it to sort of mimic human intelligence, do something complementary, go beyond?
So all of the above. The short answer is amplify human intelligence, or amplified intelligence, okay, which today is mostly human intelligence. Because intelligence is the commodity that is most in demand in the world today. If you think about, everything about, economics, politics, and everything, what we're missing the most is intelligence. I mean, when you see politicians making stupid decisions, it's because the perception of the world is wrong. They get the wrong data, or they ignore the data you should not be ignoring, first of all. Second of all, their mental model of the world is wrong. They think, for example, by establishing 50% tariffs, somehow, they're going to... they're going to repatriate manufacturing, and obviously it's not working, okay? It means, the world model is wrong, right? Then there's another way you can be wrong, is that your objective function can be wrong. If your objective function, instead of, improving the wealth of your country or the world as a whole, is to improve your own wealth, then again, you're going to not get the result that you might expect. And then the fourth time you can be stupid or evil or ineffective is not having the ability to find a good course of action. Even if your world model and your objective and your perception are right, you may not be able to find a good course of action to fulfill that goal. I actually wrote a small piece on it. If you go to my website, yann.lecun.com, there's a little pamphlet about this if you're interested.
Okay, so now let's switch to LLMs, your favorite topic, I guess, and and then we'll get to robotics. At an intuitive level, what you say makes a lot of sense, right? This next token prediction thing is not really what's going to get us to a generalized form of intelligence. But isn't it the case that if this LLM black box is able to produce the right answer in millions of cases, it must be learning some internal representation that is perhaps a version of the world model you're talking about, right? Because otherwise it just seems by fluke it cannot produce the right answer time and again.
Well, I mean, the GPT architecture, right, is the biggest ones. They have many blocks, transformer blocks or whatever, layers, right, whatever you want to call them. And so there is, some degree of reasoning just in the propagation of signals within those blocks. But it's limited because the number of blocks is finite. I mean, it's fixed. And so the amount of computation that will go into the computation of a single token from the context is fixed, which means if I ask the system, is it the case that 2 + 2 = 4, yes or no? The system, of course, will answer yes. And if I asked, and we'll do a single propagation to that thing, right? If I ask, is it the case that P = NP,